Okay. So my name's Adam Ringwood, and I'm here to talk about hash cracking, under the premise that when everything else fails, sometimes you just need to crack hashes. So a little bit about who I am. My name's Adam. I go by Avid Hacker on Twitter. I am a college student. I go to a Midwest state college. I'm the leader of ISUSEC, which is a collegiate security club that you sometimes see around screwing things up. I interned for a financial firm as an ethical hacker last summer, had a lot of fun, learned a lot of cool things. And mostly what I do in my free time is machine learning, hash cracking, and social engineering. I also kind of part-time develop for Phishing Frenzy, which is an email phishing platform. And what I'm here to talk about today is distributed hash cracking, PassCrackNet, which is basically a way to distribute your hash cracking jobs over a large number of computers. It uses OCL Hashcat, and the reason behind that is mostly because there's been a lot of really great work put into OCL Hashcat. There's a lot of really smart people who work on that and make that as efficient as possible. And I've seen other attempts at writing distributed hash crackers that, attempt to implement their own hash cracking software. And the answer is they pale in efficiency and speed compared to OCL Hashcat. So I took advantage of what was out there and took advantage of a lot of the great work that has been done in that. And I want to emphasize that most of the work has been done there. I'm simply just writing a layer on top of it to kind of move forward to a distributed kind of approach. The other thing that's significant about it is it runs over the internet, not LAN. There have been previous attempts to distribute hash crackers, mostly by on LAN attempts that have to be wired up with InfiniBand or at the very minimum gig Ethernet. And so when this project started, what actually happened is I went out onto eBay and I was like, how much would it cost me to buy all this equipment? And I went, I'm broke, too much. And so I kind of looked for a solution that would allow me to be broke and still do this. And so I ended up writing PCN. So why I built PCN, it actually started back in 2013 at B-Side Chicago. There were 4 of us sitting around a table, basically, all of which had powerful graphics cards in our respective home computers, either for gaming or home theater. And we were trying to crack a set of 10 hashes. And what could happen is we didn't have a really good way to divvy those up and, make sure that we could complete all those by the time. And so when I got home from that competition, I kind of said, okay, how would I theoretically go about doing this? And I did a bunch of research, and we played around with John the Ripper, which is another hash cracking tool. And it turns out that that didn't really work. We played around with our lab. We spent like 3 weeks trying to get it to work and never had success. And then we eventually decided on Hashcat, more because it's being updated and modern and because the developers are pretty active and you can get a hold of them. Now what I use it for is password audits. I'm working as a researcher to work with my university on doing a password audit of the university, trying to eliminate those insecure passwords that you see a lot of times being used. And then also for pen testing. Occasionally when you're doing a pen test and you've hit a dead end, sometimes you've uncovered user hashes that you have to just crack them so that you can use their account to take it to the next level. So what's different about it? There's obviously been previous attempts to build a distributed hash cracker. There's a number of them out on the internet. You can search for them and you'll see updated in 2012 or 2010. It doesn't need a local network. A lot of things have been used that require InfiniBand and 8 gigs of RAM, and everything has to be in the same room. That was a no-go from the start. We wanted the ability for, my computers in Chicago, one of my friends is in St. Louis, one of my other friends is in San Francisco. We wanted the ability to all work on this over the internet as a whole, and there was no way we were going to get everybody's computer in the same room and connect to the same network. It doesn't need a lot of RAM. You see 8 gig requirements, we have to do all this work for it, and so it's got 8 gigs. I'm a broke college student. My box has about 4 gigs. And most of them have 2, so that wasn't really an option. It's a single binary, which is easy to set up and use. I see a lot of programs nowadays where the install guides are 20 steps long, and you have to copy paste this and run this install script and make sure you get all the dependencies installed beforehand. PCN literally is just a single binary in a settings file where you specify where your hash cracker is and what server you're pointing it to, and you can fire it up and start working on tasks. And anyone can join a cluster. Just kind of copying on that, I wanted to make it as easy as possible for people to kind of get started and work on it. And I also wanted to make sure that people could leave and join at will. So, distributed networking is hard because sometimes connections drop and people can't really if you gave them a task and said, hey, I want you to do this segment of work, what happens if they drop and they no longer can complete that segment of work? How do you go back and make sure that that segment of work has been done and those passwords, if they're in there, have been found? It's also theoretically cross-platform. I don't have a lot of money, so I don't have a Windows computer and a Windows graphics card lying around to test this. But the language and everything I've done, I've kind of built with cross-platformness in mind. So if you have a Windows computer with the graphics cards attached to it and you want to be really nice, come talk to me afterwards, and I'd love to run a test on your machine and see if we can't get it up and running. It should work out of the box, but nothing ever works out of the box. So how does it work? There's actually a funny story about this. So this started back a year and a half ago. And a year and a half ago, there was no way to do it how I'm doing now. What you essentially had to do is there was a restore file that was a binary file. And you had to hunt around on the internet, and there's a single place it's mentioned, but the format of the file is mentioned on the internet somewhere. And so you had to go through, and you had to reverse this binary file, and then you had to rewrite it, and you had to make sure everything was right, because if it wasn't right, Hashcat would just fall over, and it would fail miserably. And then about, 6 months ago, the developers of Hashcat actually released the S and L flags, which are basically stand for skip and limit, and they say I want to start at this position and I want to go to this position. And thus it validated about 9 months of work on my part. But it was okay because it made the resulting work a lot easier. And then it takes a chunk of work and it reports back the results. What does it do right now? It takes a job, distributes it, supports most OCL Hashcat commands. It does wordless, brute forcing, many others. A lot of times you see GUI tools that are for the beginner or kind of hand-holdy and say, hey, you want to select this option, and if this option doesn't work with it, it'll gray it out or something. This tool makes no such promises. You should know what you're doing with OCL Hashcat before you try and run it. If you put in invalid arguments, you will run into some problems where jobs will fail over the thing. So we're going to do a demo, and I'm hoping it's going to work. Theoretically. Well, I actually decided not to do an actual demo. I did a video demo because everyone knows that shell shock is out, and I don't really want my computer pwned. Yeah, I was going to do a demo until I saw on Twitter an hour ago that somebody was running a shell shock server, and I was like, okay, well there goes that concept. So what you see here is the main jobs list. First category is the job ID. That's mostly a machine ID. Then there's the name of the job. This is put mostly in because I'm a human and I can't really remember job IDs real well, so I have to name things. Then there's a list of the tasks dispatched. There's the progress of how far along you are in it, how many results you found, and then whether it's complete. And there's also an option to pause it. So if you have a job that comes in that you need to get working on right now, but you also have a longer running job, then you can pause it and work on that. So what you see here is an overview of the task list, and it's pretty utilitarian by design. So you just see the task ID, where it started and where it finished, and whether it's done or not. This is mostly just so that you can go through and look and make sure that all the tasks are getting done. If you see a task that's buried that's false, it means one of two things. The program actually picks up tasks that are false. If it hasn't been reported back in 15 minutes, then it says, okay, the computer that was doing this work for us has dropped off the network. We need to reassign this task and have somebody else do it. And so you can kind of go through and do it. And you'll notice here that there's the false flag on the last two for 30 and 31. And that's because there's currently 2 machines in the cluster and they've pulled 2 jobs and they're each working on it. So once those come back in, they'll both be true. Now we're going to go to the create job screen. And simply you put in the job name. Try not to mistype as much as I did. Then you put in the attack mode. In this case, we're going to go with the wordless mode. The hash type is 0, which actually is MD5, which is mostly done because it's a demo. And then we're going to put in the word list. Now note that if you wanted to put rules or anything on this word list, you could throw them in the options box and it would do that. Now the other weird thing that you'll see in a second is that, notice it's also been created and it's ready. The hash file, you actually have to choose a file instead of doing anything else. And that's mostly because for certain wireless attacks, you can't copy paste the hash in there. It's actually a file you get from an output of another tool. And so if you want to load that to the hash crackers distributedly, you have to actually transmit that whole file. You can't just copy paste or send the string over the network. It doesn't work real well. I tried a couple times. It resulted in spectacular failure. It was fun. Took me like 8 hours to debug it before I figured that out. And right now what you see here is you see a mask option, so we're just doing this in. In the future, I'd like to add something so that you don't have to count how many mask characters you're typing in, because I'm really bad at it, and I almost have to do it twice. So I'd like to make something to make that a little bit easier. So now we see those 2 jobs have been inputted. You'll notice that in the process of it, well, hold on. I'm pausing job 5 because job 5 is going to take like 3 days. And so for demo purposes, it doesn't really make a good demo. And it didn't work, so we're going to do it again. We're going to unpause it and hope it takes this time. You'll notice that in the meantime, though, that one of the machines reported back and we're up to 32 tasks. So that's the machines working in the background, and they work pretty much continuously all the time. There's no data available for that task because that task hasn't been started to work on because the machines haven't gone back and done that. You can look at the output. That's the server output right there. That's the client output. It'll show you exactly what's running on Hashcat, mostly so that if something goes spectacularly wrong, it shows you the exact Hashcat command that's been run so that you can go back and rerun it and try and troubleshoot it. I will emphasize that this program is kind of in a state of breakage. If you use it well, it'll work perfectly. If you screw something up, it'll probably fall apart. So I'm just going to skip ahead, mostly because the next 4 minutes is me waiting for things to get done. Okay, so we see now that once we paused the task, it started doing that one. And then once we did that, because it's the word list, it actually came back really quick. We can see we found 2 passwords already, and those are out of the word list. Now, the interesting thing to note, and this is kind of just the thing about hash cracking in general, is the second one, which is the mask attack, which uses the exact same input file, hasn't found anything at all. And so that's pretty much an overview of it. It's a small, simple program. It does what it does well. That's kind of the goal. Problems with it, just to be completely honest. Never, ever, ever run it on a public-facing network. Please, please don't. I'm not responsible for this. Because it's taking shell commands and distributing them across the network, it is inherently insecure, and it does actually have shell injection. And I guarantee you, if you put it on a publicly facing network, you're going to get pwned in about 3 minutes flat. It's not a hard thing to recognize. Anybody competent looking at it will figure it out, and you'll regret it. There's also no authentication or anything like that. That's mostly because in the way I run it, and I recognize that's not how everybody run it, I run it on a VPN lab, and so I have people VPN their clients in and hook in that way. And that's really the way you should be running it until there's authentication added. That is one of the end goals. But please, please don't run it over the public internet. I'm not responsible. Things I'd like to do with it is better queuing. Making sure that the queuing is all... Right now, it takes the first task that's been submitted and works on it until it's done, and then moves on to the second task. I'd like to implement priorities so that you don't have to pause a job manually and unpause it. Different types of scheduling algorithms, so looking at maybe round robin and equally working on all tasks that are available in the queue and that sort of thing. Better user interface. It's a little bit utilitarian in the moment. And it communicates what it needs to communicate, but it would be nice if it was just a tiny bit prettier. And there's also user registration and security. Both those things I just kind of previously mentioned on, and I'd like to get those working. I would note that because of the way Hashcat does things, there are certain commands that if you run, it won't accept because the like, how many of you have ever used Hashcat and like run a giant job where it searches for like 1 through 8 character passwords? Those won't actually work on this cluster. It actually only will search for 8 characters at a time. That's part of how Hashcat's designed. What you actually see when that's happening is that Hashcat is actually starting 8 separate Hashcat processes, essentially, in sequential order and reporting those back to you. It's not one separate Hashcat process. And so because of that, if you want to do something like that, you have to actually fire off the 8 yourself. And I do eventually plan to put a tool kind of in there and help out with that. I think that's everything at the moment. So I did release it today. There's a client and there's a server. There's binaries out there. I don't know if they've been released yet. If not, they'll be up tonight. It's a pretty simple software. Just download it. The hardest part, and I guarantee you this, is going to be getting Hashcat running on Linux. I've only broken 2 servers at this point trying to install it. It's a very easy task, and that is completely sarcastic. AMD support is not great, so that's kind of the thing. But I don't know. Does anyone have any questions? Anything they'd like to see in it?
Yeah, I've seen Adam endorse some other solutions similar to this. Have you gotten any feedback from him?
I have not talked to him in a while. I talked to him about a year back about the S and L flags and that kind of thing, working with binary format. I'm aware he's endorsed other solutions for various reasons. Either they're Windows-centric or they're so old and they're not being maintained anymore, or they're so difficult to use. I don't feel that they're useful. Yeah. And so I kind of wanted a program that was, I believe in a philosophy that programs are small and should do what they do and do very well. And so that's why I kind of did this. I wanted to be cross-platform and usable by anyone. So that's kind of what I aimed for. But I'm aware that there are other alternatives out there. So, any other questions? All right, that's all I have.